Hi, in this video I am going to explain about Myhill-Nerode theorem. This Myhill-Nerode theorem is used to minimization of DFA, and this theorem is also known as table filling method. Basically, in this method there are four main steps. Coming to steps, the step 1 tells us draw a table for all pairs of state P belongs to Q. And coming to next point, mark all the pairs where P belongs to Q and Q is not belongs to F. What does it mean? We have to draw when the two states are is not in same condition. If the two states are in same condition, we are not going to mark that pair. Next, coming to third pair, the third step will explain that we have when there are any unmarked pairs, we have to check once more, and if the condition will true, we have to mark that pair. And next, coming to fourth point, combine all the unmarked pairs and make them a single state in a minimized. And we have to combine all these unmarked pairs and draw the DFA. And we will see how to solve this minimization of DFA by using the table filling method. Let us see. This is an example for DFA, and this is a DFA diagram, and this is transition table for this given DFA. So let us come into the minimization of DFA method. So the first step says that create a pairs of all the states involved in DFA. Here we have drawn the transition table for the given pairs, and we divide the table into each in half equal parts, and we will use only the half of the table only. Second point, mark all the pairs QA such that QA is final state and Q is not final state. We have to draw only for the state where QA and QB not in same condition. Let us see how we will draw it. First, coming to Q1, Q0, let us see Q0 and Q1 are not in same state, so we will mark it. Next, coming to Q2, Q1, Q2, Q1, Q2, Q1 are in same state, so we are not going to mark this state. Next, coming to Q3, Q3, Q0. Where is Q3? Q3, Q0. Q3, Q0 are in same condition, so we are not going to mark this pair. Next, coming to Q3, Q1. Q3, Q1. Q3 in intermediate state and Q1 is in final state, so we will mark for this. Next, coming to Q3, Q2. Q3, Q2. Q3 is in intermediate state and Q2 is in final state, so we will mark for this state. Next, coming to Q4. Q4, Q0. Q4 is in intermediate and Q3 in initial, so we are not going to mark for this state. Next, coming to Q4, Q1. Q4, Q1. These are in vice versa opposite direct condition. Next, coming to Q4, Q2. Q4, Q2. So this is also in different, so we will mark for it. Q4, Q3, Q4, Q3. These are in same intermediate condition, so we are not going to mark for this. Next, coming to Q4, Q3. Okay, it's completed. Q5. Next, coming to Q5, Q0. Q5, Q0 are in two different states, so we will mark for this. Q5, Q0. Q5, Q1. These are in same state, so we won't mark for this. Q5, Q2. Q5, Q2. These are also the same condition, so we won't mark for this. Q5, Q3. Q5, Q3. These are in different conditions, so we will mark for this. Next, coming to Q5, Q4. Q5, Q4 are in different conditions, so we'll mark this. Coming to third step, we have to check if there is any unmarked pair. If there is any presence of unmarked pair, we have to repeat the procedure until no mark can be made. And these are the pairs which are marked in the step 2, and this is the diagram of DFA. So there is a small procedure which we have to follow for mark the unmarked pairs. So this is the procedure we have to follow for the mark the unmarked pairs. By using the input symbol, we will put it into the states, and if the states are marked, then we will mark the pairs. So check for the unmarked pair Q2 and Q1. So Q2 and Q1 are unmarked pairs. By putting the input symbol 0 in Q2, Q2 on 0 goes to Q4 and Q1 on 0 goes to Q3. Check pairs Q4 and Q3. Q4 and Q3 are marked. No, it is not marked. So for next we will move to input symbol 1. Put in X2 in 1 goes to Q3 and Q1 on 1 goes to Q4. Check the pair Q4 and Q3 are marked. No, it is not marked. So hence we cannot mark the pair Q2 and Q1. This one, Q2 and Q1. Next we will go for unmarked pair of Q3 and Q0. Q3 and Q0, these two pairs. Check by using the input symbol into the transitions. Q3 on Q0 goes to Q5 and Q0 on 0 goes to Q1. Check the pairs if Q5 and Q1 are marked. Q5 or Q1 are marked. No, it is not marked. Check by using this input symbol 1 in the states. Q3 on Q1 goes to Q5, Q0 on 1 goes to Q2. Check the pairs Q5 and Q2. This one, Q5 and Q2. Mark. No, it is not marked. So hence we cannot mark the pairs Q3 and Q0. Next we will go to unmarked pair Q4 and Q0. This one, Q4 and Q0. By using the input symbol 0, we will put in states Q4 and Q0. Q4 on 0 goes to Q5, Q0 on 0 goes to Q1. Check the pair Q5 and Q1 is marked. No, it is not marked. Q5 and Q1. Q5 and Q1 are not marked. So we will go to input symbol X1. Q4 on 1 goes to Q5, Q0 on 1 goes to Q2. Check the pairs Q5 and Q2. No, it is not marked. So hence we cannot mark the pair Q4 and Q0. Next we will go to unmarked pair of Q4 and Q3. Check by using the input symbol on Q4 and Q3. Q4 on 0 goes to Q5, Q3 on 0 goes to Q5. Such pair state Q5 doesn't exist. So we will ignore it. Next we will go to input symbol X1. X equals to 1. X4 on 1 goes to X5, X3 on 1 goes to X5. Such pairs Q5 and Q5 are not doesn't exist. So we will ignore this state. Hence we cannot mark the Q4 and Q3 pair. Next we will move for the unmarked pair of Q5 and Q1. By using the input symbol 0, we will put in Q5 and Q1. Q5 on 0 goes to Q5, Q1 on 0 goes to Q3. Check the pairs Q5 and Q3. Yes, these are marked. It is marked. Hence we can mark the Q5 and Q1. This one. And next we will move. Check for the unmarked pairs Q5 and Q2. Check when input number X equals to 0. Q5 on 0 goes to Q5, Q2 on 0 goes to Q4. Check Q5 and Q4 are marked. Yes, these are marked. So we will mark Q5 and Q2. We will mark on Q5 and Q2. We will mark on Q5 and Q2. Hence we mark the Q5 and Q2. We have checked for all the unmarked pairs, but we don't want to stop here only. We have to repeat this process until no mark can be made. So we are going to continue this process until no mark cannot be made. So we are going to check for the unmarked pairs Q2 and Q1 once again. Q2 and Q1. Q2 on 0 goes to Q4. Q1 on 0 goes to Q3. Q4 and Q3. Q4 and Q3 are marked. We are going to check is this are marked or not. If there is no mark on these states, we are not going to mark. If the states are marked, we will mark on the current state. So it is not marked. Q4 and Q3 are not marked. So we are not going to mark in Q2 on Q2 and Q1. Check for when X equals to 1. Q2 on 1 goes to Q3. Q1 on 1 goes to Q4. Check the pair Q4 and Q3 are marked. No. So hence we cannot mark the pair Q2 and Q1. Check for the unmarked pairs Q3 and Q0. Q3 and Q0. Q3 on 0 goes to Q5. Q0 on 0 goes to Q1. Check the pairs Q5 and Q1 are marked. Q5 and Q1. Q5 and Q1 are marked. So these are marked. So we will mark the Q3 and Q0. The same process will be repeated to those two unpaired steps, and up to here the step 3 will be completed. Next we will move to the step 4. In step 4 we will combine all the unmarked pairs and make them a single state in a minimized DFA. The unmarked pairs are Q2, Q1 and Q4, Q3. And we will combine them into a single state Q2, Q1 and Q3, Q2, Q1 and Q3, Q4. By using these two states, we will minimize the DFA and draw the minimized DFA. And this is the final DFA which we are obtained by using the table filling method to minimization of DFA. And this is all about minimization of DFA by using table filling method. Thank you.